Hi dear students, in this video we are going to see a very important and interesting concept, electric field lines. It is very important concept for your examination. In most of the question paper you can see this question, but not only that, you have to understand this electric field only with the help of the electric field lines. In fact, you cannot see electric field lines anywhere around the charge. We are not able to see the charge, we are not able to see the electric field, but how the electric field will be around the charge, that can be visualized by the electric field pattern. In fact, this electric field pattern from the observations, from the experiments, we manually draw to understand the electric field. So this is only visual concept, so visual understanding to comprehend about the electric field. Now let us discuss some of the properties of the electric field lines, and that is the point here we are going to discuss in this content. Okay, let's go. Okay, right. First point, if you consider a positive charge, what will be the direction of the electric field? The electric field line will always originate from the positive charge. If it finds any negative charge nearby, it will terminate at a negative charge. Otherwise, it will go up to infinity, it will end at infinity only, right? So this is the first point. In the case of positive charge, the electric field lines will originate from the positive charge and it will terminate negative charge if any nearby, otherwise it will terminate or it will end up with a negative. In the case of negative charge, here the direction is marked, right, is radially outward. The electric field lines are radially outward. In this case of negative charge, what happens? See, the electric field lines, they come from even infinity and terminate at the negative charge. It comes to the negative charge, it is pointing towards the negative charge. As far as the negative charge is concerned, the field lines are directed towards the charge. This we have already seen. So for positive charge, the electric field lines are directed outwards, and you can see the direction here. As far as the negative charge is concerned, the electric field lines are coming towards the charge. This is the first point and second point. Okay. Now, if we have positive charge and negative charge side by side, what happens here? The positive charge, the electric field lines originates from the positive charge and terminate at a negative. See, you understand, it does not form a loop. So in magnetic field lines, we will see the magnetic field lines will form loop, whereas the electric field lines originate from the positive charge and terminates at the negative charge. It will not once again start from negative and comes to positive. That will not happen here. So you can see this. So electric field lines start from positive charge and terminates at a negative charge. Every field lines following the same things like that. Okay. So all the lines are starting from here, positive charge, and they are terminating at a negative charge. That is another important point. Then if you want to find out the direction of the electric field at any point along the electric field line, you just draw the tangent at that point to the electric field direction, then you will get the direction of the electric field at that particular point. See, if you want to have electric field line, so இங்கேயே நம்ம draw பண்ணி காமிக்கலாம். So if you want to calculate the direction of the electric field, if you want to find out the direction of the electric field, at this point I just draw the tangent to the curve, and the tangent will show the direction of the electric field. So tangent will show the direction of the electric field at every point. If you see the direction, definitely here the direction will change. If you draw the tangent will show the direction. At every point you can see the direction how it changes. Correct? So to find out the direction of the electric field, you just draw the tangent at a point to the curve. You will find out the direction of the electric field. Yes. No two field lines intersect each other. That is very important point. Here also you can see in this pattern, no field lines will cross each other. So all the points will follow in its own way. So they never intersect each other. Suppose for an argument, if I say that if it intersects each other, what will happen? At a particular point, you can have two directions. That is practically not possible. Suppose if you are walking along the road, at one point you can walk in one direction. You cannot walk in two directions. That is the concept. In a similar manner, no field lines will cross each other. If it crosses, definitely at this particular point they will have two different direction at a particular point at particular instant. That will not practically not possible, right? So no field lines never intersect. Okay, that is a point. Then another important point is positive charges here, the field lines are radially directed outwards, and see the point charge here, it is minus 2q. So when the magnitude of the charge increases, the number of field lines also increase. That we can understand here. In this case of positive q, we have 4 lines, but in the case of negative charge 2q, then you will have double the numbers, 3, 6 and 8, and also pointing towards the charge. So when the magnitude of the charge increases, the number of lines directly proportional to magnitude of the charge. This is very important to solve some problems. Okay ba? Yes. And finally, we already know that the electric field is inversely proportional to square of distance, right? So when electric field is strong, then the number of lines crossing through a particular area perpendicular to the direction of the electric field is much more high. So that is the strong field. In the case of weak field, the number of lines crossing through a given area perpendicular to the direction of the field will be less. That we can understand from the diagram. Also we know that nearby the charge, the electric field is much stronger. When you go far away from the charge, the electric field will be weaker. So here I am placing two surfaces which are perpendicular to the direction of the electric field. Here the number of lines crossing through the area is more because the electric field is stronger here, because the distance is very less from the charge. Whereas this area is placed at some distance, because the distance of this area is less, distance of this area is more. So distance more means electric field becomes less. So here you are having a weak electric field, therefore the number of lines also passing through the area is very small. So these are the very important properties of the electric field lines. So electric field lines are nothing but a straight or curved continuous lines. To understand the concept of the electric field, to visualize the electric field, if you want to visually see the electric field pattern, you have to draw the electric field lines. So all the field lines are continuous lines. It doesn't matter whether it is a straight line or curved line or curve. So definitely all are continuous. They are not breaking up anywhere. So these are the important properties of the electric field lines. We will meet in the next video. Thank you.